first, we are going to go over prime and composite first today, okay? We have to understand prime and composite before we can understand what prime factorization is. So, from your agenda, I need you to click on Tuesday's prime and composite assignment. You're going to be using your computer and your notebook kind of together today. So, when you're in your agenda, I need you to click on the prime and composite assignment. I'm going to pull up GoGuardian real quick so I can show you how to look at this from a computer perspective. Okay, perfect example. Aubrey, I'm going to use yours, I think. Aubrey, go back one screen for me. I'm going to use yours as an example. All right, so stay here for just a second, Aubrey. When you click on the assignment from the agenda, you're going to come to a screen like this. Okay, it'll say prime and composite. This is where eventually you will click to submit this assignment. Down here is the actual Google Doc, but it's often hard to work on because it's small. Okay, when an assignment is set up like this, like Aubrey already did before I made her go back, you can click on right here where it says prime and composite, and it's going to open up a full-size Google Doc for you that's easier to work on. Okay, so not yet, Aubrey. Let me go over it again. So when you go from the agenda and click on the assignment, it's going to pull up a screen like this. You can work down here on the bottom half, but it's a little hard. Okay, it is much easier if you click on the Google Doc link here, and then it'll make it full screen. So Aubrey, go ahead, and then you'll be good. All right, so then you should have a screen that looks like this, except I need to get rid of some stuff. Forgot to delete this earlier, sorry. Oh, why is my mouse like that? Okay, so first thing we're covering today is what prime and composite is. All right, possibly heard these before. Okay, this is something you're turning in, but we are doing it together. So therefore, when you submit it in a few minutes, it should be completely correct because we're going to go through it together and talk about this. The reason why I'm having you do this as an assignment is this chart is something you will want to refer back to often until you kind of get a hang of what the prime numbers are and what the composites are. The more you do this, the more you're just going to memorize, yes, that's prime, yes, that's composite. Okay? Everything gets easier the more we do it. All right? So once you submit this, one, it'll be in your Google Docs where you can pull it up whenever you want to. And two, you will be able to access it through your grades in Canvas also. Okay. Now, since I already had the descriptions typed on there when most of you opened it, it's already on your screen. So I'll just type it again. If it's not on your screen, we're going to explain what prime and composite are. All right. So a prime number, okay, and just bear with me because I know a lot of this may be new this year. A prime number is any number that only one times itself will give you that number. Now, I always kind of explain this differently every time. So those of you that opened it up when I still had the definition on my Google Doc, I may type it slightly different, but it still means the same thing. So a prime number is, if you don't have it, you'll have to type it. Any number that only one and itself can be multiplied to get the number. I almost say it the same. Mm-hmm. Sometimes I do pretty good. Let me see if I can make this a tad bigger for you. There we go. Okay, and that'll make more sense once we start filling in this chart. But a prime number is any number that the only thing you can multiply to get that number is one in itself. You can't multiply anything else to get that number in order for it to be prime. So then obviously composite is kind of the opposite of that. All right, a composite is any number that has more than two factors, right? Or more than two things can be multiplied to get that number. This will make a lot of sense in a second. So here's what you need to do. You're going to take and highlight the definition in the word for prime, and then you're going to go up here to the little highlighter and highlight it yellow. Then you're going to highlight composite and that definition, and you're going to highlight that one green. So in our chart, in a minute, all of our prime numbers we're going to turn yellow, and all of our composite numbers we're going to turn green. Okay? Now at first, we're going to have to kind of go one by one, but eventually we'll see a pattern. Okay? Now, the number 1 is not considered prime or composite. Anyone know why based on those definitions? A prime number is any number that only one in itself can be multiplied, so it has two factors. A composite number has more than two factors. Okay? 1 is not considered prime or composite because the only thing it is 1. It doesn't have a factor. It is just 1. It's itself. So it's not prime or composite. Again, we're going to go one by one to start with, but then we'll see some patterns. The number 2. Is there anything besides 1 times 2 that we can multiply to get the number 2? Yes or no? No. No. So we are going to highlight the number 2 yellow because it is prime. Okay, I will go somewhat slow, but you're going to have to focus and stay with me. John, there is no way you can do this with a computer closed unless you just have some amazing powers that I need you to share with me. The number 3. Is there anything we can multiply besides 1 and 3 to get 3? No. No, therefore it is also prime. So we are going to turn it yellow. The number 4, anything besides 1 and 4 that we can multiply to get 4? 2, absolutely. So is it prime or composite? Composite. It is composite because it has more than 2 factors. So we're going to change that one green. The number 5, anything besides 1 and 5? No, so it is yellow because it's prime. The number 6, anything besides 1 and 6? Leah? 3. So therefore it is going to be what color, Leah? Green because it's composite. You have 1, 2, 3, and 6. So it's got more than 2 factors. 7 going to be yellow or green, prime or composite? It is going to be yellow because only 1 and 7. The number 8, what do we think? Prime or composite? You can just nicely say it. I hate to say yell it out because I don't want you literally yelling it out, but you can say it out. How about that? Number 8, prime or composite? Composite. It's going green. You have 1 and 8. You have 2 and 4. So there's more than 2 factors. The number 9, what do we think? Prime or composite? Composite. Composite. What besides 1 and 9? 3. 3. Perfect. And the number 10, what do we think? Composite. We have 1 and 10. We have 2 and 5. Okay? So our first row has several prime numbers. You will notice that gets less and less the further we go. Okay? 11. Prime or composite? Prime. That one would be prime. There's nothing besides 1 and 11. Now, moving on to 12. Okay? 12 ends in what kind of a number? Even number. What do we know will go into all even numbers? What number? Mason? 2. So, If 2 goes into all even numbers, we can knock out about half of these numbers right now. Okay? So, if you notice, I set these up as a like tens chart for a reason. All of these numbers underneath 2 end in a 2, which means 2 will go into them. Therefore, they are all what kind of numbers? Composite, because they have more than 2 factors. So you can highlight 12 through 92 and turn all those green because 2 goes into them. Now 2 is prime, but everything that 2 goes into is composite because it has more than 2 factors. Then we can skip right over to the ones that end in 4. Those are all also even numbers, which means 2 goes into them, so they are what kind of a number? They are also composite. Okay. Then if we move over to our even numbers that end in 6. All right. Obviously, if they end in 6, they're even and 2 goes into them, so they are what kind of numbers? Prime or composite? If 2 will go into them, they are composite, so they are green. Then we can move over to our 8s. They end in 8, which is an even number, so therefore are they prime or composite? Same answer as the last 3 times. Composite, so they're going green. And then our last even column ends in 0s, which makes them even. Therefore, 2 goes into them, so therefore are they prime or composite? They are composite. Thank you, Jordan, for participating. Okay, so we just knocked out half our numbers. So that helps, right? I want to talk about this row, our 5 row. Way back in kindergarten, one of the first things you learned to do was count by 5s, right? Count by 1s, count by 5s, count by 10s, probably 2s also. If a number ends in 5, what will always go into it? Think about when you counted by 5s in kindergarten. 5, 10, 15, 20, 25, 30, da, da, da. If a number ends in 5, what prime number will go into it? 1, yes. What else? 1 goes into everything. 5. So therefore, all of your numbers that end in a 5, 15, 25, 35, 45, 55, 65, 75, 85, 95, 5 will go into them. Therefore, they are also composite. Okay, so we just took care of a lot of numbers based on what you don't realize is those are called divisibility rules. Okay, 5 goes into any number that ends in 5 or 0, but we had already got our zeros knocked out. So now we have a lot less numbers to go through. We're going to go one by one for now. 13, what do we think? Prime or composite? Prime. It is prime, so we're going to go yellow. Skipping all the way over to 17, what do we think? Prime. Also prime, so yellow. For some reason, I'm making them gray. I'm not quite sure what I'm doing. Sorry. 19, what do we think? Prime. That one is prime. Now, some of them will trick us, but we'll get there in a minute. 21. Why? What else goes into it besides 1 and 21? 3 and 7. Perfect. 23. It is prime. 27. What goes into it? 9 and 3. See, you guys know this. You may just not have known what they were called. 29. Got a 50-50 chance. 29. What do we think? Oh. Yes. Okay, so in our 20s, we only have 23 and 29. 31. Somebody's got to think something. Prime. I agree. Yellow. 33. I hear little things. What do you think? So it's composite. Okay. And you said what goes into it, Jordan? Because I want to talk about that. 11. How do you know 11 goes into it? What about it should you automatically know 11 goes into it? It's a double digit. Okay. So we need to look to see, do we have any other double digits? Because 11 goes into them. Well, we already took care of 22, 33, 44, 55, 66. So we can change 77. Because if it's a double digit, 11 goes into it. So 77 is going green. We already had 88. And we can change 99. Okay, that's another one of those divisibility rules you'll just eventually pick up on. If it's a 2-digit number and they're the same number, 11 goes into it. Moving on to 37, what do we think? It is prime. 39. Oh, I keep changing it to gray. Sorry. 39. I've heard both. Not prime. Can anyone tell me what goes into 39? 3. Okay, for those of you that are understanding divisibility rules, again, not something we necessarily have to learn yet. You can find out if 3 will go into a number very easily. Add the two numbers together, like 3 and 9, that's 12. If 3 goes into the sum of the digits, the number is divisible by 3. So I know that 39 is divisible by 3 because 9 plus 3 is 12, and 3 goes into 12. Okay, again, you'll get to that eventually. 41, what are we thinking? One or the other, it's prime. Jordan's going to do amazing on this. 43, what do we think? It is prime. 47. It is prime. I gotta go change my 41. For some reason, I'm sticking with gray. 49.
Composite.
Yes, some of you were very quick with that. Why? What do you know goes into it?
7.
Yes, that's just one we should automatically know. So 49 is composite because 7 goes into it. 51. It is not. Can anyone tell me what might go into it? It's not a fact that we learn, but a divisibility rule I just briefly said would help us. What is 5 plus 1?
6.
What will go into 6 that I mentioned?
3.
3. So therefore 3 goes into 51, I believe 17 times. 53. It is prime, yellow. 57. It is not. It is composite. This is that rule again. What is 5 plus 7? Will 3 go into 12? Therefore, 3 goes into 57. Okay? That's why we're doing this together. 59, what do we think? It is prime. So in the 50s, we just have 2, 53 and 59. 61, we're almost done. It is prime. 63, careful. Composite, what goes into it? 3. 6 plus 3 is 9. 3 goes into 9. 67. It is prime. And 69. It is composite. 6 plus 9 is 15. 3 goes into 15. 71. It is prime, yellow. 73. It's also prime. I know these are more just a guessing. These are not necessarily facts we have memorized. And then all the way over to 79. It is also prime. 81, we should know this. What goes into it? We should know 9 goes into 81. 83. It is yellow. 87. It is not. So this is where the 3 comes into, like if you could learn this divisibility rule, it's super helpful. So what is 7 plus 8? 15. And 3 goes into 15, therefore 3 goes into 87. Okay. 89. It is prime. 91 is a tricky one, and I have to look it up again. Oh, I did 89 in gray again. 91 is composite. I always think it's 17, but it's not. I will figure it out. Sorry. 91 is composite. I have to figure out exactly what it was. 93. It's composite. Mason, what goes into it? 9 plus 3 is 12. Therefore, 3 goes into 93. Okay. And 97. It is prime. 97 is your only prime number in the 90s. Okay. So the yellow are all your prime numbers. They only have 2 factors. The green are all your composite numbers. They have more than 2 factors. Now, what you need to do is go back to that other tab where you can click submit. Once you click submit over there, it will tell you submitted on such and such at such and such. Okay. Until it says submitted next to it, I didn't get it and you're not getting your points. Now I need you to leave this on your screen. I'm not going to be able to leave it on mine. And then we need to look at these notes. So now using those prime numbers, we can talk about prime factorization. Okay. You will want that list. So hopefully during your warm-up time, you already got this written down. So prime factorization, we are going to use a factor tree to find all of the prime numbers that you can multiply together to get a given number. Okay. I think of factor tree as like a family tree. Now, used to a long time ago, you may remember seeing this hanging in your grandparents' house. People would hang like a picture of their family tree. You have like the main person, maybe grandma or grandpa. Then branching off of that is their children. Then branching off of that is their children. That's a family tree, which will look very, very similar to a factor tree that we are going to use with prime factorization. With prime factorization, it is called prime factorization because we are using prime numbers. So you will only be using your yellow numbers when you are done. And you're basically just looking for factors. So that's why on your warm-up, I was asking you to find factors of numbers. So if I give you the number 36, okay, and this is going to be your ticket out my door. You will show me this page right here with your notes to get out at the end of class. So unless you want to be late to your next class, you need to take your notes. So 36, we're going to make a factor tree, so we're splitting it off. Factor trees can start out different ways because there is more than 2 numbers that you can multiply to get 36. But when you are done, your prime factorization will always be the same. Okay? So, Mateo, when you hear the number 36, what's 2 numbers you think of that you can multiply together? Perfect. Okay? Someone else may have done 2 and 18. It doesn't matter. As long as what you're saying multiplies together to give you that number, your prime factorization at the end will be the same. Okay? Now, neither of these are prime, so we're not done. We have to have all prime numbers. So both of these, we have to split apart again because neither of those numbers were prime, and this is called prime factorization. So we don't use 1 because 1 is not prime. What can we multiply to get 6? 2 and 3. Are either of those prime? This is why we made a chart. Yes, they both are, so we're going to circle them because we're done. You will circle prime numbers. Then obviously this other 6 is going to be broken up the same exact way, 2 and 3. So now you have all prime numbers at the end of all your branches. So your factor tree is done. Then, to write the prime factorization, you have to use these 4 numbers, and they need to go smallest to largest. So we are going to write this as 2 times 2 times 3 times 3. Anyone know why I'm using dots for multiplication instead of x's? You will not see x's very often from now on for multiplication. Why? Why do we use dots instead? Mateo, what do you think?
Because in some problems they use like solve X.
Yep. So you will see x used as what's called a variable instead of being used as a multiplication sign. So you will see the dot more for multiplication than you will for the x. X can still mean multiplication. You're just not going to see it as much. All right, let's do a factor tree for 72. Okay, again, you can start it a different way than other people as long as the 2 numbers actually give you 72. So what is 2 numbers, or what are 2 numbers that we can multiply to get 72? James? 9 and 8. Okay, you could have done 2 and 36. Like there's plenty of options to start with. Neither of those are prime, so none of those get circled, and now we have to branch off both of those. Okay, so let's deal with 9 first. What can we multiply to get 9? Leah?
3.
Yep, and you have to use both of them, 3 and 3. 3 is prime, so we're circling both of those, and that side is done. What can we multiply to get 8? Mateo?
4 and 2.
4 and 2. I'm going to put my 2 first just because I'm running out of room there. 2 is prime, so I'm going to circle it. Now I have to deal with 4. What can I multiply to get 4? Jordan? 2 and 2. And those are both prime. So you have all prime numbers at the end of your branches. Your prime factor tree is done. Now, to write your prime factorization, you have to include all the circled numbers. There's 5 of them, and they need to go least to greatest. So the prime factorization for 72 would be 2 times 2 times 2, because I've got 3 2's. You could always gently cross them off if you're afraid of forgetting one. And then I have my 2 3's. So times 3 times 3. So the prime factorization for 72 would be 2 times 2 times 2 times 3 times 3. All prime numbers. We'll eventually learn how to write them with exponents, but we're not going there today. All right.